So welcome everyone in problem solving and doubt clearing session number 11 of the course MA91 Production Technology Theory and Practice. Okay, so first of all we go with assignment for week number 10. Okay, so this is the assignment for week number 10 and this is the first question for it. Which among the following is a lathe picture used to ensure concentricity while machining outer diameter? Okay, so collect is different thing. Okay, you know this term surface plate and wave block is completely different. Demanded is the correct answer for the coexcentricity. Okay, for coexcentricity, what we can use the mandate only. Okay, in case of length, so that is the correct answer. Each small division on Meyer scale of a vernier caliper is 0.025 unit. Vernier scale is 25 division, and this coincides with 24 division of the main scale. The least count in the vernier caliper in units. Okay. So how we can calculate it? Means you know in my assignment I told you if you go on through it. Okay, so how you can calculate for a 1 year scale will be 1 by 25 into s 24 division is coinciding into and what is the point it gives a main scale. Okay, so this answer you will give to, so this will be your answer of this. Okay, so if we need to calculate the least count now, so this how we can calculate least count. I explained everything in the previous assignment. So how you can calculate least count here? You need to subtract this on the main scale, each division on a main scale to this part. Okay, so what it will be? So your answer will be 0.001. Okay, so what I told you previously also, what we did here actually we subtract this on main scale. Okay, each small individual on the main scale of 100 caliber. Okay, this part on main scale we subtracted from the maximum part of your 1 year scale. Okay, that I told you in my assignment also. Exact part I'm telling you right now. Exactly how this question can be solved. Okay, this is your from one main scale and this is from 1 year scale part. So exactly this part we can solve. So this is your answer. What is your answer here? 0. Yes, this exactly okay. We need to know just how to subtract it and how to calculate this part because this 24 division is coinciding in case of 25 division on 1 year. And each 1 year scale division counts on main scale is this. For each small division on main scale, this is the value that can be measured. From this, what you can get, this can be your discount in units again because it is mentioned in units. So this will be discounted in units. This some units in this part. Okay, so third question: which of one of the following manufacturing process will be likely to result in best surface finishing? Okay, so arc welding is not give a highest surface finish. Okay, or surface finish highest means this peak to value distance is less. You know this part. Yes, this part must be less. Okay, so which process will give with less? Machining will not give. Most likely, okay, best surface finish machining will not give. Ekdam best sand casting will give actually give off, which is big no here. Grinding will give. Sawing also not. Okay, so grinding only can give you this kind of this less part is like this surface undulation is very very less. Okay, this is only given by grinding process. Okay? All of them will do high part. Okay, like this arc welding, machining, sand, and just give you high surface finish. Yes, high surface roughness, less surface finish, high surface roughness it called, and this will give you high surface finish. You know the difference between that part. Okay, right now, because I in my assignment I told you many times. Okay. Okay, so this give you high surface finish. Okay, that's why we go for grinding process. You know, this is your fourth question. Each one of the following device defines the tolerance the best. Total clearance between shaft and mating hole. Odd mating hole is wrong. Measures error. Okay, the total permissible difference between the variation from a specified dimension. Okay, this is only the best suitable for your tolerance. Okay, other definitions are that variation in manufacturing is not tolerance. Okay, this is a different thing. And permissible variation is called as your tolerance. Okay, which is permissible. This is variation in manufacturing is not permissible. Okay, the permissible is called a tolerance. Measurement is again not. And the clearance between shaft and mating hole is not called, it's called fit again. It is a different concept. So it is not tolerance, it's actually allowance. This is tolerance. Okay, so this, no, this is completely different. Okay, so for tolerance, this is only a correct answer. This is the fifth question. Essential condition for obtaining an interference fit is the lower limit of the shaft should be greater than upper limit of the hole. Okay, so this is the correct answer. What this actually does means, yes, consider this is your hole. Means this is like a part. Consider this is a part, and this is your hole here, and the lower limit of the shaft. Consider this is the lower limit. So the lower limit of the shaft should be greater than the upper limit of the hole. So this lower limit of the shaft must be greater than the upper limit of the hole. Due to which what will happen? This is your shaft considered. Due to this what will happen? It will create an interference field. Okay, so this is a proper condition for an interference field. Okay, due to this thing, the interference may happen. Okay, so because of your shaft is bigger and the hole is smaller. Okay, this will be a shaft and the shaft is bigger and the hole is smaller, due to which there is a kind of interference field. Okay, so this is only a correct answer from first part itself. Okay, so the essential condition for obtaining a clearance field. Okay, so exactly opposite case will be there right now. The lower limit of the hole should be greater than the upper limit of the shaft. Means what actually here they are meaning, the lower limit of the shaft is wrong. Okay, no. Lower limit of the shaft because it is for previous part. Right now what will happen? The lower limit of the hole should be greater than upper limit of the shaft. How? Consider this is your lower limit of the hole. Lower limit of the hole means this is your smallest hole. This is your small hole actually. Okay, this is a small hole and should be greater than the upper limit of the shaft. Upper limit of the shaft will be a bigger shaft. So this will be a biggest shaft, bigger shaft. So this will be your bigger shaft. Okay, so due to this, what will happen? There is always gap between this. This gap is called your clearance field. Okay, this gap is called as its clearance field. Okay, so this condition is correct. Okay, it is possible to do 25 millimeter nominal hole to an accuracy of is 25 plus or minus 0.02 millimeter. Using a standard drill, shaft is to be machined to obtain a clearance fit in our hole such that the allowance should be. I think see the things allowance comes here. I told you in previous question that allowance part came into picture. Allowance and tolerance are different. Okay, so this is the concept again. Should be 0.01 millimeter, and the maximum clearance should not be more than 0.08 millimeter. Tolerance on the shaft in millimeter should be. Okay, so as I told you in previous question also, in my previous question also I told you, okay, and my assignment also I told you what actually I mean by my previous question here in this part. Okay, this gap is called as clearance fit. So what we want actually clearance fit only. So how we can get a clearance fit here again? So what is the part for your hole now? 25.05 because we know what is the part. This 25 plus or minus 0.05. So what you will do? This is for your hole. Exactly like previous I will solve for you. Okay, this will be hole, and for your this will be your hole max upper limit, and this will be your mid, that is lower limit. Okay, okay, so right now what we want, the allowance clearance with hole such that allowance should be this, and the maximum clearance should not be more than more than 0. So it can be that part, but should not be more than. Okay. So the more important point is it should not be more than. It can be equal to, but not be more than. Okay. So for that part, how we can solve now? For upper limit of shaft, what we have 24.98 minus 0.01. Okay, which should must be there. Okay, that allowance must be there with you. So how we can do that? What you are actually trying to find upper limit of the shaft, and what we have the lower limit of the hole. Means lower limit means this lower limit of the hole. But what we want here the clearance width. This is the lower limit of the hole, and you must have at any cost you have. This is the lower limit. Means lower limit is small, your small hole, and this will be your big shaft. Okay, as you are want upper limit. So and this must be there. So what is the upper limit for the shaft? Just subtract this part. What you will get 24 point. Okay, this will be good. And right now what we want lower limit of shaft. So what does this actually mean right now? You have so what they're actually asking here should not be the clearance maximum clearance should not be more than this part. So more should not be more than means consider this is your what we define the lower limit of the shaft. This is your small shaft, and the gap between the small shaft and your bigger hole should not be more than 0.08. Okay, so consider this is a bigger hole. This will be your bigger hole, big hole, and this gap should not be more than 0.08. So it can be 0.08, but should not be more than this part. Okay, so more than this is not considered. Okay, only less than this is considered. Okay, so less than this is correct, but in case more than this is wrong. Okay, so less than it is only correct. So we want less than this part. Okay, but can be is equal to can be equal to or less than. So for that we need to go provide lower limit of your shaft. Okay, because it can be less than or equal to, but should not be 0.09. Okay, if you go for 0.09 it is wrong, then it become completely wrong part. Okay, it must be less than that. Okay, it must be less than your this or equal to this. Okay, so your clearance part. So if you go to this part it is considered as wrong. So what we can do, this is your bigger hole now and small shaft. So this is your bigger hole, and how you can get your small shaft by subtracting this 0.08, which can be equal to. Okay, less than you can take, but can be equal to means this can be taken into consideration. Okay, up to that value it is permitted. So up to 0.0 value it is permitted. Therefore, what we get 0. This 24.94 millimeter. And how you can get the tolerance here? So tolerance is equal to uh, your upper limit of shaft, okay, minus lower limit of shaft, because we need to calculate for shaft. Okay, dimension for shaft. So what will happen here? Just subtract this. So we'll get 0.03 millimeter as your answer. Okay, this will be your answer. I think I showed you. Okay, 0.03 is your answer. Okay, I'll show you how you can calculate it. Okay, this is part. Okay, so moving forward. 8th question. With smaller tolerances, the cost will increase. It's very obvious because we use high precision machines, okay, high accuracy. Okay, for small tolerances. Okay, due to which the machining cost will increase. Cost, okay, inspection cost, again the rejection cost. Okay, so everything will come into picture. To which what will happen? The cost will increase. Okay, this every thing will be come into addition of this part. Okay, so this will increase. This is the correct answer. Difference between the basic dimensions of meeting part is known as, I told you, allowances. Meeting parts is called allowances. Okay, tolerance is different thing. Between the basic dimensions of the meeting parts is called allowances. And limit is different, clearness is different. Allowance is only correct part. Okay. Rotation has to be transmitted from a shaft to gear counter unit. The feed between the shaft and the gear it is like running feed, swing feed, two speed is wrong answer. Interference only. I told you because it will be locked and it will to transfer power. Okay. Or what? Transfer power or motion. Okay. Power, oblique motion. What you can do is transfer. This interference bit only can be used okay, to transfer. So we completed the assignment problem. Right now we go for practice problem set. This is the first question for your practice problem set. Okay, so in block G28, X minus 10, Y20, Z10, G28 stand for what? Okay, so end program is wrong here, okay. Cancellation of the cutter, radius compensation is wrong. Didn't collision is you know. Anyway, this is only the correct answer. Okay, so your G28 stands for what? Return to reference point. This is your reference point coordinates, and this point it will go. Second question in block G01 Z minus 2 formulae Z2 stands for. Okay, so in block G01, Z minus 2 for milling, Z minus 2 stands for what? Radius of profile is wrong. Is it interpolation? Is this not Z minus 2? Okay, circular interpolation of is wrong. So what only left with you? Z. Depth of cut for milling. I told you for milling what Z dash means. It will be depth of cut for in case of milling. Okay. So radius, it is not radius. Either interpolation is 0, 1 for, but they are not asking here. The property that asking here is different. It is asking Z. So the Z0 zone is not asked here. Okay, so it is not correct. Circular interpolation is completely not correct. So only the Z minus to stand for this part. Okay. Depth of cut. So depth of cut will be the correct answer. Third question, in block G41 H11 for milling, H11 stands for. Okay, so in block G41 H11 for milling, H11 stands for offset value for a 2 reduce compensation of tool number 1. Okay, this is correct because we are going for H11. So what is actually stores value. Tool reduce compensation left hand is wrong. Digit interpolation depth of cut is wrong. Because why what we are asking here? H11. If they are asking G41 then this might be correct. But for H11 this is wrong. So only offset of the two radius is your correct answer. Okay. Offset value for radius of tool compensation is only your correct answer. In block P01 M06 G43 H1 for milling, G43 stands for. Exact similar kind of question, but here now we are asking for G43. So H1 is for your offset value, but right now it must be tool. It must be tool. L is missing here. You can see when we will give the H1 tool value for tool length compensation only when you have that command active. Okay, so G23 must be equal to your tool length compensation command, and that is only the correct answer. Total compensation command. Okay, because you're asking this G43 here, which is equal to total compensation, and the value is this. This is your value by using H denoted this value, and the command that can be activated using G43. Okay, so this is the correct answer. Question 5, in block G77 R1 for turning, R1 stands for this R1. G1 G77 is again different command, and this R1 is again check. So you have to check this part. G77 is different and R1 is different separate command, but it is interrelated to each other. In what way you have to check? Okay, so if you go through the tables part and literature, you may know that this G77 actually stands for curtain cycle x-axis, and this R is actually your retention height. So field and approach reference is wrong. You know it is G28 is for that. The field is different. So for G77 command cycle, this curtain cycle x-axis, the R is denoted by your retraction height. Okay, so the retraction height is correct answer. Okay, so this retraction height is correct answer. Okay, so this as we are using it in G77. Okay, and asking for R1. Sixth question, in block G73 P40 Q7.5 U0.2 W0.2 for turning, G73 stands for. So it is very easy right now because you know the way it is written, it must be some kind of cycle. It is stock removal cycle, and this is G73. We made it. This is in form of cycle. Okay, so here no nothing is actually in form of cycles. What is the answer? Stock removal. Stock removal is on there because this you can say this is 23. From the previous experience, the question that previously asked, we might get this part. The G73 is calling command right now, and this is the part in that command. So here the G73 might be a calling command at depth of the printer. These are not other calling commands. Only this is only cycle available in options. So this is only the correct option. There is no any different part to think about. Okay, this is only your correct answer. So in CNC part programming, M98 stand for. Here not to go from the literature part. Okay, so to apply your brain and apply your brain means go to the part literature and slides. See what is the correct answer. M98 you are asking me is again machine code. It is not your G code. It is different. It is for miscellaneous machine code. Yeah, that is geometric code that is different. This is your miscellaneous code, which is for machine operations. And it is not G, it is M. So it does not have any kind of geometrical part. for cutting between part. Like it is machine, your machine equipment part here. That is of end program, sub program call. It is for machine part. It is for machine. The program is rendered or reset to start. It's for your machine part. They don't have any commands for your geometry part. Okay, so it is M code. So this is what they are asking in the sixth seventh question. Six is about different part, and seventh question. Six is about your in the stock cycle, which is about geometry. See, they are giving you P. Q. P is again part of your program, and U and U is actually your higher distances only. So this is, it can be part of G. This is your geometry part, but this is your machine part. That's different. So I told you M98. Okay, so end of the program, reset start is different. The sub-program call is your correct answer. If you go from the literature, it is simple. Program end is not, and program end is again M02, M99. 3 or 2, I don't know, but it is not part. This is for M99 and M98 is for sub-program call. I think it's M02. Go check it. So check this part, but mostly it is M02, but this is your this is M1998. Okay. So sub-program call is the correct answer. This is the eighth question. Rotation can be transmitted between two parallel and coplanar shafts by. So right now we're shifting from your CNC part programming to transmission, that is gear drive parts. But this is a part of your assignments mostly. So these kind of questions are assigned usually in assignments, asked in assignments. So that's why you are going for such kind of questions, so you can get practice in hand before going for actual solving of assignments. Okay, so right now we're going for drive part. Okay, so rotation can be transmitted between two parallel and co-brother shafts. So important is parallel and co-brother shafts. You can take your time to solve. Okay, so if you go from the slides or literature part, if you listen the slides, so for two parallel and coplanar, Spurgeon is the correct answer. Okay, so belt it is different. It's not usual for parallel and coplanar both. Okay, and if the chain and sprocket also can go for don't go for coplanar path. It is slightly different. Okay, so only this is correct answers for wheel gear is for 90 degree. You know. So belt drive and chain and sprocket is a wrong concept here. Okay. So only for parallel and coplanar, spur gear drive is correct answer. Okay. Ninth question. Which drive can be used to transfer motion between two shafts rotating in both same and in opposite direction? Both in same and opposite direction. Okay, so both is very important part. Okay, so you must know this part. Both is important here. So if you go from literature, the spur gear can't transfer in both direction. Neither bevel gear, only belt drive can. Neither sprocket door it will entangle everything. Okay, only belt drive can both like in both. What is important here? Both same and opposite direction. Okay, only belt drive can do this part. Okay, so belt drive is correct answer. So 10th question, which drive converts rotary motion into linear motion and vice versa? Means linear to rotational, rotary. So which drive does that? That is the question. If you go from the literature or the slides, you might get the answer is rack and pinion. Okay, so rack and pinion can do rotary into linear motion and linear into rotation. Rotary both. Rack and pinion drive. That's why it is used in steering mechanisms. So rack and pinion drive is the correct answer. Considering a situation in which one required high gear ratio and motion can not be transferred from output to input, which drive you will use. This is a condition for you in which gear ratio must be high and it is not transferred from output to input. So this kind of situation we have. So what drive you will use? That is the question. You can take a more time here if you want. You have to go for literature part and solve this correct answer. So if you go from the slides or literature part, you will quote the answer for high gear ratio and motion cannot be transferred from output to input. This is only possible in worm and worm gear. So this is only possible in the worm and worm gear part. Okay. So your worm and worm gear will be only your correct answer here. Okay. What? High gear ratio and cannot be transferred from output to input. Okay. Your correct answer. So 12 question again we have this different kind of condition but similar question type. Okay. Consider a situation which requires to convert rotary motion to intermediate rotary motion. Which drive you will use? Since you never I can put in worm and worm grip, all of the above or none of the above. To create an intermediate rotary motion. So here most important part is intermediate rotary motion. Again from rotary to intermediate rotary. Okay. So, so if you go through the literature part, you might get the answer. It is actually Genova mechanism. Okay, so rotary motion to intermediate rotary motion part is in the Genova mechanism used. Okay, you know this part. So you saw this mechanism also. Okay, for the Genova mechanism. Okay, so the Genova mechanism is going to be the correct answer here. For intermediate motion, which is the most important part in this question. Okay, so the Genova mechanism is correct answer. So, choose a 13. Which gear drive can be used for steering mechanism of a wheel? It's again a simple kind of question. So, you might be get the answer again. I obviously told you that I can clearly be used for steering wheel mechanism in case of steering to move the wheels. Okay. Steering mechanism I can pinion convert rotary motion to linear motion. Okay, to rotary motion to means your wheels axis. Okay, so this rack and pinion drive is correct for steering mechanism of a vehicle. Which gear drive can be used for lifts? Okay, again this is application based question. So from various point that what we actually need for lifts, that is the part here. So what needed for lift? Okay, again the power should not be transmitted from output to input, because if suddenly power cut happens, you should not the case that power is transmitted from your output to input, so it suddenly fail. The lift will suddenly go down. So this should not be happen. There must be a kind of locking mechanism. If sudden kind of power failure, there should be some kind of a locking mechanism. Okay. So which have a locking mechanism? Thing that has locking mechanism is only the concept that can be used here. So which of these having a locking mechanism that can be used as a lift here? Means as a drive here for lift. Not as a lift, but gear drive as a lift. Gear drive for lift. Okay. Which has a this locking condition. This locking part you have. I told you the answer was close to that. So that is what you should think in that direction of locking part. It should not be failed down. If it means it must have a proper gear issue also, and the failing part should not be there. Means power should not be transmitted from the output to the input. That is part. Okay, so we might get that answer very quickly if I told you the gear point of it. Okay, this is actually a previous question we have. So okay, just think about it, apply the proper logic here, and you can get the answer. Okay, so what required here is locking mechanism is power should not be transmitted. And again, you can have this high gear ratio again. So high ratio and the power should not be transmitted from output to input. Okay. So this output to input power should not be transmitted. Okay. So this is the most important in case of lifts. Okay, so in case of lift, this part is more important. So prevent it from failing. So again, high gear ratio output should not be passed through this output and output input transfer should not be there. So only your worm and worm will have such kind of situation. Such kind of condition will be satisfied by worm gear drive. Okay, so high gear ratio output transfer to input power with input motion. So it is only can be suitable for your lifts. Okay, so worm and worm gear drive will be a correct answer. Okay, this is a 15th question. Which gear drive has or have up to which of them have a gear ratio up to this such kind of high gear ratio which is up to 14:1. So which of these have a drive ratio up to 14:1? So it is actually told in one of the not slides, one of the part in the videos in the classes. It is told that we can have drive can have gear ratio as high up to 40 estimates. So which drive system has that? That is the question. You can easily go to literature and tell the answer here. Okay, so if we go to literature again, the answer for highest gear ratio or having up to 40 as to 1 is over drive is only a correct answer. If I go to literature part, is only you get correct answer. Okay, so again, for and one wheel drive is only a correct answer for gear ratio up to 40 as to 1, such a high part. Okay, so again, you have condition like if you want to increase in speed, so how you will conduct as per gear drive? You want increase in speed, that's more important. How you can connect? Again, this is our the applied based questions. You have to think, apply your brain, and you can answer it. Okay, increase in speed is important. Means what in what fashion you should connect your smaller gear and your larger gear. Again, this is part. Okay, the small gear means your pinion and large gear. So connection between these two. Okay, you can think about it. Then go to literature or slides and you can answer. If you go on to literature and slides, get the answer. Okay. So for increasing speed, you need A. So A is the correct answer. Okay. Means what is the relation right now? Smaller gear to the output and larger gear to input. So like this is your input right now. This is your output. So if it is rotating at 20, depending upon the gear ratio, like it has some 40 teeth, it has 20 teeth, means double only. So right now this will rotate at 40. So your speed got increased. Okay. That's how the gear part will work. Okay. This will increase your speed of this to 40 because it is mostly half. The number of things depend upon, but the connection should be like that only. The figures came into picture when you actually give the number of treatments, the actual values came into the picture. But just like overall, if you see what the way it should be connected is like this only. Okay, if you go deeper into the calculation, then that exact poly units and the figures will come into picture at the amount you want. But overall, how it should be like this only. Okay, this is it. This is the transfer line. This is the transfer line. Okay, this is 20 and this is the 20. So this can be reversed. So your rotation is increased here. Okay, you can get increased speed at output. Okay, so this is A, your correct answer. 17 is like that, but right now we want increasing torque. So increasing speed and increasing torque is different. Okay, you must know this part that increasing speed and torque is different. So increasing torque, you have to calculate now. Torque means you need a larger gear to get the torque. What is torque means? Force into R mostly. So for that you need more R means more diameter, means more size, means larger. So where you need to connect, you need to think. Okay, and after that I will solve this question. For right now it is for torque. Okay, as I already told you that for more torque you require more diameter, so larger wheel for longest wheel must be R for torque. So R will be there. For more torque, you required more diameter. Okay, because it is transfer at the periphery mostly. So more diameter means larger output. Okay. More diameter means more larger output. So your larger gear must be at output. So here your larger gear is at output. Okay, so this is the correct answer. For torque option, okay, I told you this B part is your correct answer. So you have to change here, it is torque actually. Okay, so your B is your correct answer. 18th question. In bevel gear drive, a gear with 35 teeth is being driven by another bevel gear with 10 teeth. The rotation transmission of bevel gear drive is this very simple question. Just Google literature, you will get the answer. Rotation transmission of the bevel gear they are asking here. That's it. So here, what is the concept actually? The in this bevel gear, the gear with 35 teeth is being driven by another bevel gear with 10 teeth. So means bevel gear with 35 teeth. Think this is bevel gear means is how to this plane is perpendicular to each other. Okay. So 35 teeth is being driven by another gear. So this is considered 35. 35 means it is driven by this. So this is your input. This is your output portion. Okay. Now define the rotation transmission of the how its rotation is transmitted to that. That is what we calculate. So that must be kind of ratio. Okay. How much transmitted to that part with respect to 10? How much motion is transmitted to that part? Because 10 is driven by 10 is actually your driver and 35 is driven. So 10 is driving by 35. So you are okay. So what actually things is happening here? 35 is getting driven, isn't it? So your smaller gear is driving bigger gear. So your speed must be reduced. So it must be less. Must be less than 1. Okay, so whatever your answer that will came, it must be less than 1. This x is here. Okay, this x must be less than 1. That's it. And again up to 2 point we can round up. Okay, mostly up because it is less than 1, so up to 2 point we can round up. 2 decimal. Okay, so what your answer will be? So your transmission means rotation transmission is equal to, I just write like RT. Okay, yes, RT is equal to this part. Your RT is equal to 10 by 35. Okay, so 35 is your, I told you the list means it's 10 by 35. It is your driver and this is your driver actually. So it must be less than, so answer is 2.2 okay, 2.8, like it is 5.7 up to, but we need to keep it up to 2 decimals only. So this is just division. This is just to divide. As I told you, up to 2 decimals, so it is 2857. So it's converted to 0.29. So 0.29 will be your answer. So exactly like that, we have checked question. Exactly be in your dream. Okay, but here is a twist. Why? Because you can see a gear with 40 teeth is driven. Right now, what is happening? 40 teeth is here, and your driver is bigger right now, 65 teeth. So your speed must increase here. Acceleration will be more than one. That's what it is. I need to take a ratios only, but it's more than one. That's how we need to solve it. Okay. So I told you you must take the ratio here. So that I'm writing that RT is equal to this is your driver and this is driven by. So this is your driver is driven. This is your driver. So driver is your up and driven is down. So you can get from the analogy also that it must be more than one. And again to two decimals after point. Okay. Yeah. This is your ratio of RT can be converted to 1.23. Yes, yes, 1.6305 times. Okay, so here this one can be transferred to 3 and this 1.63 is the correct answer. Okay, so this is your 20th question. It is exactly similar like previous one, but what you are using here, you are using spur gear. That is only the difference. Okay, but I also want to find out RT again. But what we are using spur gear. That is only the difference. And here, what is the question? A gear with 15 teeth is being driven by another spur gear with 100 teeth. So, what here actually they are asking? So, this is consider this is your gear with 15 teeth, and this is your gear with 100 teeth. Okay, this is the 100 teeth, and this is your with 15 teeth. This is this part. So, right now, from this part, okay, you can get this part that this is your 15 teeth is being driven. So, this is your driven, and this is your driver. Okay, so from this part you can get that your RT is more than one. Okay, this your RT must be more than one. Why? Because your you see your driver is 100 teeth having, and this is your only 50 teeth. So the rotation of these teeth will be increased. Okay, hence the rotation transmission will be increased. So it will be more than one. Okay, so you can calculate in that way also. Okay, so use the exact same way and get the actual. We know it is more than one, but exact by what value one here you have to calculate it. Okay, to calculate it exactly by same way, you know how to calculate it exactly like that you can calculate. And just remember that your driver has 100. Okay, being driven by this is your driver and this is driven by. Okay, so by this you can calculate your rotation transmission for us first 4 gear. Okay. If you know what is your RT, that is means your rotation transmission, and write it as RT. Okay, this is your because it is a rotation transmission. Right now, just write it as RT. Okay, so what is the formula for RT? You know this part. It will be this is your driver. Okay, so I told you it must be more than one. So this is only we can get more than one. Okay, and that answer goes to up to 6.67. Okay, this must be recurring form, but this is 6.67. So your answer is 6.67. Okay, because this is your driven and this is your driver. Okay, as you saw you. So driver is having means you know it is actually bigger. Your driver is bigger and your driver is small. So your speed must increase and increase. That's why rotation RT must be more than that. And how much more than that? You can get by this simple formula. That's dividing your this driver by your this driven part, and this answer comes to this point. So by how much it is more, you know it is more than one, but how much it is more? It is 6.67. This is your answer. So again, this is exactly same. This is per gear and everything we are using, but here a gear with 200 teeth is being driven by another spur gear with 100 teeth. So right now your gear with 200 teeth is being driven. So consider this is your gear with 200 teeth. This is by 80. Okay. This is a gear with 200 is being driven. So this 200 is driven by 80. Okay. So you can get your RT will be obviously less than. But how much amount you have to find by formula. Okay. So this is your driven. This is your, you see, gear width 200 is being driven by another spur gear width of diameter of, not diameter, of teeth 80. So this is your driver. Okay, if you got the point, okay, so your RT means your rotation transmission percentage is RT, which is equal to 80 by 200. You know how, because this is your driver, and from the formula you know that this is your driven part and this is driver part, so it must be less than 1, but by what amount? It's 0.67. Again we are using 2 decimal point only, okay, as previous one. Okay, as we are using only 2 decimal point here. Okay, so your answer is 0.67, as it is actually recurring from 66666, but 67 we are using only 2 decimal, so 0.67 is your correct answer. Okay, see, 0.67 is your correct answer. Right now we are going for other set of problems which is actually important for assignments. Okay, for a 75 mm diameter cylindrical workpiece being turned on a lathe, the cutting speed is more than the rotation frequency by how much times? That is the question here. You can go to literature if you try to solve it. Okay, you can take your own time to solve this question. In slides also you got the answer, okay, which is equal to pi dm. So the rotation frequency is right now is like n, and you have your d. So what you do here? Pi into 75 into n. So this is a more than rotation frequency. So n can cancel. So this is pi into 75 is your actual answer up to 1 decimal. So what the answer is 235.6. Okay, so this is the correct answer. Just need to multiply this 75 into pi, you get answer. That's it. Because you know v is equal to pi dn, and this n is equal to rotational frequency. Okay, so this is the that part is actually the rotational frequency to this. So about time rotation frequency with what, neglect this part, and only this is your answer. So this gap is actually filled by this part only. Okay, so 235.6 your correct answer, which we got by multiplying the 75 pi. 75 again your diameter is given, so it's very simple problem. Just multiply by pi, that's it. So this 235.6 is the correct answer. Then similar kind of question we have here, just 30 we have done here. Solve it by your word. You can take more time to solve this. It's exactly similar to the previous one. Okay, just 30 change rather than what we have. The 75 you have previously, right now at 30. That's it. Okay. It's exactly same. You can solve it. Okay, by your own muscle. Okay, so by the time you got the answer, okay, so what you need to do here is to find the cutting speed is equal to pi d n. So what is d here? 30, and n is your rotation frequency, which is into times. So your v is equal to pi into 30 into n, because it is again you have to cancel it here. So v is equal to pi into 30 will be 94.30. Is actually round off values. Okay, because you are round up to one decimal, so you can get up to 9.4.3 only. Okay, so this is only 3 up to here. Okay, so this 3 was the only correct answer. Okay, 94.3 is the only correct answer, because it is 4, so you can convert it. Okay, so this is 4, you can convert it into 4. Okay, the 3 can be converted into 4. So just multiply this pi, okay, into the 30, so we get your answer. That's it. This is equal to 94.3. So okay, this 34, but into rounded up to one decimal only. So this will be your answer. Okay, 94.3 is your answer. Let's end this filling blank. So again, we have similar kind of question. 94th, again, but rounded up to two decimals here. And what we have here, change is diameter change, but here we are 1 times per second, and the frequency is in RPM, rotations per minute. So that conversion here you are asking here. Mostly need to divide it by 60. That is the part. What I need to do here, okay? Okay, from previously you know that your cutting speed V is equal to pi dn. But what why they are asking here? Times per second. Times, okay, times per second. By more than the rotation frequency in RPM by times per second. So you know V is equal to pi d n. Here the n is in RPM, actually rotation per minute. So for converting into second, you divide it by 60. So here what it will be, V is equal to means V is equal to pi d by 60 into n, because you have to find times n. Okay, so there n we need to cancel it. Yes, because it is times n. So that we should consider. It will be pi into 45 by 60. Okay, so this answer will be the 2.36, because you have to round it off. Okay, so round it off, this 6 might be pi, but due to round it off process, it came into 36. Okay, so 2.36 is the correct answer, which is per second. Okay, you need to see this is per second times. Okay, per second times. So this is the per second times. Okay, 2.36. Right now, similar question we have here, 50. Exactly same question, but we are changing the diameter here. That's it. V here. Okay, so you know V is equal to pi dn by 60. Okay, as previous formula, you know, because this is an RPM, which is mentioning, you have to take it to seconds. So what it will be, pi into 50, go into 60, because we need per second. Okay, so this will give you the answer. Okay. we will 2.62 and up to 2 decimal. That is again important part. So 2.62 will be your answer per second. Okay. So this is 26th question. In gear cutting process, the mechanism used for correct rotation of blank is called as. Okay. Right now, we're changing our focus to different, which is important for your assignment part. Okay. So in gear cutting process, the mechanism used for correct rotation of blank is called as. What we use it for correct rotation of blank for gear cutting process? That is the question. Okay. The index mechanism is the correct answer. The gear drive. Okay, so for correct rotation of a blank in gear, we are not using gear drive, which is a mechanism and for gear. So only using the index mechanism. It's called as indexing mechanism actually for correct rotation of blank to get correct gear profile. Okay. For correct gear profile, what we want here, we want correct gear profile. So for that correct gear profile, we need indexing mechanism. Okay. For proper rotation. Okay. So your indexing mechanism is the correct answer. The presentation in gear milling process again. The milling cutter is connected to harbor through what? So this is your support, and the shaft that comes here from that. This is again your support. Okay. This part is again your support here, and so this is where the gear is mounted. Okay. Your gear cutter. This is a where blank is mounted. Okay. So this is your cutter. So if you see the part, okay, you get the answer. The correct answer is key. It is connected to key. Here is the key slot. You might see the part. Okay. But if you see the part, you might see the key part. Okay. While inserting that key in case of it was dual gear. Okay. So you might see that. And also in case of per gear, you see that in the actual slides. Okay. This is a key here. It is used for connect harbor, the milling cutter to harbor. So gear drive and wheel drive is wrong. Okay. So key is the only correct answer. I show you also. And explain you here. You can see clearly the key part. Okay. Here the key is here. In slides you can see it properly. Okay. So key is the correct answer here. Okay. You can tell how drilling operation is performed on lathe machine. Okay. So how the drill is actually being done on lathe machine. That is the question here. Okay. If you know the lathe machine, so how drill operation is performed on lathe machine, placing drill bit on a tailstock, placing drill bit on a two headstock, placing drill bit on tool post or none of the above. So drilling a bit in headstock is because you have to place the shaft actually here. Drill bit in tool post is a way wrong. So placing drill bit in tailstock is the correct answer. Okay. So you know the tailstock is used in that tailstock you use a drill bit to do the drilling operation in lathe machine. Okay. On lathe machine. So 29, how to create a cylindrical taper surface on lathe. So right now what we ask here, how to create a cylindrical taper. So this is the taper like something, okay, on the slides also. So you generate this kind of part. So how you can do here? The proper aligning of headstock. Okay, this is wrong. Proper aligning of headstock. Okay, this you can do by surface by this. Okay, so only proper aligning of tool post is the correct answer. How you can do that? By properly placing tool post. Okay, so you know how in this fashion the it is like this. So your material will be removed in this part. Okay, like this fashion, like material will be removed, not this. Okay, so like this way the material will be removed if you align your tool post correctly. Okay, because it is anyhow it is rotation in rotation. So like you have to properly align your tool post in such a way that this your tool post will cut. This is a tool. This tool will properly cut. This your tool consider a tool, and this tool properly go through this side and cut the taper part. Okay, so properly aligning the tool post, and when the tool will be there inside it, so this will be correct answer. Okay, this will be the correct answer. So 30th, in the lathe pressing operation is performed by on lathe. How the pressing operation is performed? No pressing operation. Okay, this is this is your shaft. So pressing operation is done on this place. Okay, here. Okay. And this side. Okay, like this way we do the field perform the spacing operation. What kind of field it is? So I told you the answer here itself, because what you will consider the field you consider here. So important concept is field here. Surface, the way we giving the feed. The facing can be done by form tools. It is for counting part you can use, but facing can be done by form tools. Wrong. It is not correct. Simply holding the one piece in a three jaw chuck. The chuck is just used to transfer the power so that rotate our shaft. That's it. That is the concept of your chuck. Three jaw chuck or four jaw chuck is just to transfer the power or to rotate the machine to provide a cutting velocity with the shaft. There is no any concept of fishing operation. We can do turning also by keeping it or replacing the other. We can do drilling also. We can do everything there. So this can't be specific for spacing. So only I told you, okay, the feed, the way the feed is given. Okay, so providing cross feed is only correct answer. Okay, the way the feed is given, the only the cross feed can give you the spacing operation. Okay, so giving cross feed is the only correct answer. Okay. Okay, so providing a cross speed is your correct answer for tracing operation. Okay, so what unit of tracing operation you are asking here? For tracing operation, providing cross speed is out of the two is the only correct answer. Okay, so this is the 31 question. What is use of central drill bit? So why we use the central drill bit? For turning operation for keeping it between two centers, we need to have a central drill on our shaft. If your shaft is very big, your shaft length is very high. Okay, so if your length is more like very high, so what you need to do? You need to keep it somewhere. Okay, okay, so for this you need a center. Yeah, so that center, how you create this center is required. This center to keep it. So that center a little bit. So what's the use of that? Okay, you see this part to keep it there. Okay, so how that is performed? That how that is created? So that's the question. That center bit is used for that. So actually, for what? How you can use the center bit? So here, what is actually your length is very high. So you need such kind of mounting. Okay, so we can keep it straight. Okay, straight is very important for the operation. Okay, as it is long, so keeping straight is difficult. So we are going to use this kind of part to keep it straight. So that kind of thing you know. So how that is how to generate that? That's the question. So what is the use of the central drill bit? Actually, I told you the answer here. Okay. Okay, if you got this point, the central drill bit is used to. Okay, so I told you here itself. Okay, this is the central, and why it is central drill bit used for? Hold the shaft around to drill a hole in the center of the shaft is a correct answer. Okay, I told you this diagram itself. Okay, so this center is done by using central input, and this can be used for to hold the long shafts. Okay, to hold the long shaft is it is application, but use of center bit is to drill the hole. By drilling the hole, you can hold it. Okay, so here only this is your correct answer. Okay, to drill the hole in the center of the shaft is your correct answer. Okay, so read the perpendicular to the shaft is wrong, one of the page wrong. Okay, so only this is the correct answer. So only this is the correct answer. Okay. So we drill a hole in the center of the shaft is only correct answer. Okay. So which part of the drill bit is used to remove the drill from the sleeves? Okay, so again, correctly completed question. Okay, you can take your time. Okay, you need to consider the drill bit properly. Okay, here. So neck, body, fluid, and time. Okay, if you go through the actual how the drill bit is, so like tang is at the most part. Then you have somewhere you have neck. This is a shank part. And you have your body part again. This you have flutes. So here this actually has a flute part actually. So some have flutes. Yeah, and you have a body also. You have somewhere here you have neck. I think so. So this part is actually the tank. This is your drill bit, and between this part you have. And the flute don't have anything to move from the sleeves. Your body also don't have, and neck also don't have anything to move from the sleeve. So only the tank is the correct answer because tank is like a part here, the flattened part here, like this. This is part like you have. Okay, so this part like you have at the top, it is called as tank. Okay, in the consider this is your tail bit and this is the tail part, tank part. Okay, which is used to remove from drain from the sleeve. Okay, this part actually. You can check the grid geometry. This part is tank and this is used to remove from the sleeves. Okay. This tank is the correct answer here. Okay. This tank is the your correct answer. So this is the last part, last question of this 11th week. Okay, so here we concluded the problem solving and after session number 11. Okay, so you need to submit your assignment by Wednesday. So do you submit your assignment by Wednesday? Okay, so thank you for your attention. Thank you.